Hello and welcome to this next lecture involving examples in probability. So we're going to start looking at examples of functions of random variables. Supposing you have two random variables which have a joint distribution, and I have a function of those two random variables. The function could be the addition of those two random variables, subtraction of those two random variables, multiplication of those two random variables, the minimum of those two random variables, maximum of those two random variables. There are any number of functions that you can think of. And given the joint PMF of two random variables, how do you find the distribution of the function of those two random variables? Now, this is a very, very important example. It comes up again and again and again in any probabilistic model, and it's very important to know how to go about doing it. So I'm going to take a few simple examples. You saw probably Professor Arvind do slightly more complicated examples, and I'm going to take simple examples and start reinforcing the ideas. Okay, so let's start with the first example I'm going to take. Okay. So I'm going to consider an example where x and y together take values in this form. So x takes two values 0 and 1, y takes three values 0, 1, 2, and I'm going to say all the probabilities are 1 by 6. Okay, so this is my joint PMF. So x and y are, this is my pxy of x comma y. Okay. There are two random variables x and y, and the joint PMF is given like this. Okay, so when you're dealing with functions of random variables, and the random variables are very small in some sense, right? So they take only very few values. It's useful to write tabulation. Okay, so you can write a simple table and then deal with all functions in a very nice way. So I like that method. We could call it a table method if you like. So you can just list out all the possibilities and write the functions and find the probabilities. It's quite easy to do that. So let's do that. Okay, so you have x here, y here, and then it's convenient to write, say, pxy of x comma y in this fashion. So x could be 0, y could be 1, x could be 0, sorry, let me just write out 0, 1, 2, or x could be 1 and then y could be 0, right? So all the joint PMF is just 1 by 6 for all these possibilities. Okay, so now if I want to find a function, let's say I'm interested in the function x plus y. Okay, so if I'm interested in the function x plus y, so you write like this, and then you write down what x plus y is: 0, 1, 2, 1, 2, 3. Okay, or maybe I'm so now supposing I want to ask the question, what's the probability that x plus y equals 0? Right. So this is my x plus y. This is a function I'm interested in. Okay, and what are the values that x plus y takes? Right, from this table you can see that x plus y is another random variable, and it takes four values 0, 1, 2, 3. Okay, so I know that for sure. Now I can ask the question, what's the probability that x plus y is 0? So in this table you see 0 occurs only in this first position, and that occurs with probability 1 by 6. So it's quite easy to read out that this is the probability of this. So in fact, from this table, what do you read out? You can see that this probability is actually the same as probability that x equals 0 comma y equals 0, and that is 1 by 6. Okay, quite easy, straightforward. Supposing you ask the question, what's the probability that x plus y is 1? Okay, from the table you can see there are two possibilities here. There's a possibility here for which x plus y is 1, and there's a possibility here for which x plus y is 1. Okay, so x plus y is 1 actually corresponds to two cases here. X is 0, y is 1, or x is 1, y is 0. Okay, now this is 1 by 6, this is 1 by 6. Together you get 2 by 6. If you want, you can write it as 1 by 3. Okay, so that's the probability for x plus y is 1. Okay, so now you can keep continuing. Supposing you say, I'm interested in x plus y is 2. Again, from the table, you can quickly see that there are two possibilities here, so you'll get 2 by 6. And you want to look at probability that x plus y is 3. This is one possibility, so 1 by 6. Okay, so if you write it all together, you have here 1 by 6, 2 by 6, 2 by 6, 1 by 6. Okay, this is a very easy method for small distributions. So if you notice here, in this case, actually x and y are independent. So in the independent case, for sum, you also have a simpler expression for computing the sum. It's the convolution of the two marginals. So that's also possible. You can do that also in this case, but it's a small example. Things like this are very, very easy to do. Now suppose somebody asks you to find x minus y, right? You can just keep continuing on this table. So what is x minus y here? Minus 1, minus 2, 1, 0, minus 1. So that's it. So and then you ask the same question, what's the probability that x minus y is 0? You simply add these two guys, you will get 2 by 6. What's the probability that x minus y is minus 1? You will get 1 by 6 plus 1 by 6, again 2 by 6. What's the probability that x minus y is 1? 1 by 6. What's the probability that x minus y is minus 2? Again 1 by 6. Okay. So it's just easy to write this down, and one can see that this table method is quite easy to do for any function that you want. So supposing I want min of x comma y. Here you have minimum is 0, 0, 0. Here you have 0, 1, 1. Okay, supposing you want max of x comma y. You have 0, 1, 2, 2, 1, 1, 2. Okay, so suppose somebody were to ask a question, just from this table you can answer any question you like. So supposing you want to ask what's the probability that min of x comma y equals 0, right? So you have 4 possibilities here, 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6, that's 4 by 6. Supposing you were to ask what's the probability that max of x comma y equals 1. There are 3 possibilities here, 1 by 6 plus 1 by 6 plus 1 by 6, that's 3 by 6. Okay, so for small examples like this, it's very, very, very convenient to simply write down the table, write the joint PMF, and then evaluate whatever function you want. Whatever the function may be, you can quickly write down the answer, and you can write down all the things. So if you notice, the table also tells you everything. So for instance, the table tells you that max of x comma y is a random variable which takes 3 values, 0, 1, 2. Okay, and then its PMF can be calculated quite easily using the table. Okay, so this method is kind of bread and butter. It's a very simple method. It works in small situations when the random variable becomes quite complex and you can't enumerate it quite so easily. But this is not a bad way to visualize how you're doing functions of random variable. Okay, so I'll keep coming back to this method because we're going to be dealing with simple examples in this lecture. Okay. So you can consider other PMFs. So instead of 1 by 6 throughout, you could take some other PMF and the same method would continue, right? So there's no real problem here. So every time you have a case, you just go look up the PMF probability and then keep adding the corresponding values. You will get your answer. Okay, so hopefully this method is clear in that fashion. Okay, so let's look at one more example, which is maybe slightly bigger, so may not be that easy to do. The second example we take, let's say we throw a die twice. Okay, so I'll say x is the value of first throw, y is the value of second throw. Okay, and I'm interested, so remember x and y are both independent. They take values from 1 to 6 with uniform probability, and joint PMF is also simply the product. Okay, so joint PMF is just 1 by 36 for all the pair of possible values. So if you want, you can actually write down a table. It's not very hard, but it's going to become big. It's going to have 36 values. Okay, so it may be it's probably a little bit better to try and see if we can cut short the calculations a little bit in some case. So let's say we're interested in x plus y. Okay, so this is the function for which we want to compute the PMF. The first step always is to understand the range of values that your function takes. Okay, so x took values from 1 to 6, y took values from 1 to 6, and the joint PMF, all possibilities are there. So x plus y will take values from 2 to 12. Is that okay? Think about it. It can take value 2, 1 plus 1 will be 2. It cannot go below that. It cannot take a value 1, right? So you have to visualize this thing and understand that x plus y would take all these values. And then for a particular value of x plus y, you need to find out the probability. So for instance, I might be interested in the probability that x plus y equals 2. Okay. So the important thing is you have to break it down into the possibilities for x and y individually. Okay, so x plus y is 2 means x has to be 1, y has to be 1. That's the only possibility, right? So this event corresponds to x equals 1, y equals 1. So this is the same as probability that x equals 1, comma y equals 1. And from the PMF, I know that's just 1 by 36. Okay. So if you want to push ahead and see what is x plus y equals 3, so here you will start having more possibilities. You could have x equals 1, y equals 2, or x equals 2, y equals 1. There are two possibilities here. So the probability is simply probability of x equals 1, y equals 2, plus probability of x equals 2, y equals 1. So that's 1 by 36 plus 1 by 36. It's 2 by 36. So we can proceed like this. So if you look at probability that x plus y is 4, okay, you'll have three possibilities for x and y together, right? 1, 3, 2, 2, 3, 1. Okay, so that will become 3 by 36. Okay, so on you have to go, but you have to be slightly careful. So this will go for probability that x plus y is 5 also. So how many possibilities would have? 1, 4, 2, 3, 3, 2, 4, 1. So that's 4 possibilities. Okay, so likewise 6 is also okay. 5 by 36. 7 is also okay. 6 by 36, right? So up to 7, you'll have 7 would be like the maximum possibilities will come, right? So 1, 6, 2, 5, 3, 3, 4, 2, 5, 1. No, yeah, 5, 1, right? So did I get that right? Yeah, so okay, I'm sorry, x plus y is 7, 5, 2, and 6, 1. Okay, so let me repeat this. For x plus y equal to 7, you will have the maximum possibilities 1, 6, 2, 5, 3, 3, 4, 2, 5, okay, so let me repeat this once again. X plus y equal to 7, you have the maximum possibilities 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. So these are the 6 possibilities for x plus y equal to 7. So now when you start going a little bit higher than that, if you want say x plus y equals 8, you'll see x cannot be 1. You know, if x is 1, x plus y is not going to be 8. It's because y maximum is 7. So the number of possibilities will decrease. So here you will have, for instance, 2, 6, 3, 5, 4, 4, and then 5, 3, and then 6, 2. There are only 5 possibilities, 5 by 36. It will start falling off. Okay, so you can notice all these kind of patterns. It's also possible to use convolution in some sense to compute this sum, though I will not talk about it here. So 9 will be 4 by 36 and so on. Okay, so all the way till 12 will again become just one possibility, 1 by 36. Okay, so this is I mean, I just wrote it down exhaustively, but you can see how to think of functions and do it in this form. So you have to understand how many possibilities are there in x and y, and simply just write down that probability. There's nothing much more to happen here. So let's look at a slightly more interesting maybe function. Let's say min of xy. So now min of xy, if you think about it, it's x takes values from 1 to 6, y takes values from 1 to 6. The min of xy will take value 1, 2, 3, 4, 5, 6. Right? So this is the possibilities for min of xy. And then you would ask the question, what's the probability that min of xy equals 1? Okay, here again you have to smartly count how many possibilities are there. So if you look at it, 1, 1, 1, 2, so on till 1, 6, all of them will give you min 1. Not only that, you can also have 2, 1, 3, 1, so on till okay, 4, 1, 5, 1, 6, 1. Okay, all of these possibilities are also there. So there are 5 here, 6 here, 6 plus 5, 11. 11 by 36 is the possibility of min of x, y being equal to 1. So even for 2, you need to look at it, min of xy equal to 2. Remember, it's equal to 2, so you can have 1, no, it cannot have 1, 2, right? So it should be 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and also 3, 2, 4, 2, 5, 2, 6, 2. So that's 4 plus 5, 9 possibilities. It will go on like this. So you can have probability of min of xy equals 3 would be 7 by 36. Probability of min of x, y equals 4 will be 5 by 36. Probability of min of x comma y equals 5 will be 3 by 36. Probability of min of x comma y equals 6 will just be 1 by 36. See, 6 is the easiest because you only have one possibility, 6 comma 6. Okay, so one very useful thing to do when you compute probabilities like this is to make sure that they all add up to 1. Okay, so that's a good check to do. You can see 11 plus 9 is 20, 27, 32, 35, 36. Okay, so that adds up to 1. So you know that you've not made a very glaring mistake. It'll still be wrong, but this is less likely that you're wrong. Okay, so this is a good way to compute probability. So you can see I'm actually using only the table method. It's just that I'm enumerating in whenever required in some smart way and quickly observing some patterns and going about doing it. So when you have functions of random variables, this is what you do. Now there are some generic methods. Professor Arvind refers to those methods. You should look at those methods also very closely. When you have like min or max, there are general ways in which you can think about how to compute these things. So that will also help you. So those are very, very important to understand as well. But so some simple examples are also nice to see. Okay. So the final couple of examples I'm going to do are slightly more complicated. Okay. So this is the third example I'm going to do. I will look at balls into bins. So the first case we'll consider is, let's say we are throwing 5 balls into 2 bins. Okay, there are only 2 bins. Remember, this is a bit critical. Sometimes you can get misled by this problem. There are 2 bins, bin 1, bin 2. And you're throwing 5 balls into these bins, right? So 5 balls. So let's say x is the number of balls in bin 1. And y is the number of balls in bin 2. Okay, so now we might start asking for questions about what is this distribution. So one needs to be a little bit careful here with this distribution. It's not very straightforward. Now x takes how many values? You can see x takes it could be 0, 1, 2, 3, 4, 5. There are 6 possible values that x can take. And if you look at the joint distribution, one needs to pay a little bit of attention here. So supposing you put x here, y here, and say x is 0, 1, 2, 3, 4, 5. Okay, what are the possible values for y? Remember, there are only 2 bins. The ball either went into bin 1 or went into bin 2. So if I say the number of balls in bin 1 is 0, what should be the number of balls in bin 2? It has to be 5. Right? So there can't be any other possibility. Okay, there are only 2 bins, and this restricts the number of possibilities that there can be. So if the number of balls in bin 1 were 1, this has to be 4, this has to be 3, this has to be 2, this has to be 1, this has to be 0. Okay, so x and y are kind of heavily dependent. In fact, they determine each other, right? So x is 5 minus y. X plus y has to be equal to 5. Okay, so that's the important thing about this this experiment that we're doing. It's a very simple connection between x and y. Okay, so if you were to look at pxy of x comma y here, okay, so what's the probability that all the balls fell into bin 2? So this would be just like half power 5. Okay, so 1 in this case, so you would have like, this is just binomial. When you think about it, what's the probability number of balls that fell into bin 1? It's just binomial 5 comma half, right? So that's the kind of thing you have to do. Here you will have 5 choose 1, again half times half power 4. Okay, so well, it's just writing it in a laborious fashion. This is hopefully you see where I come where this is coming from, right? So there's exactly 1 ball in bin 1. That's with probability half. There are five different ways in which it can happen. It could be the first ball or the second ball, or the third ball, or fourth ball, or fifth ball. 5 choose 1. And then half power 4 means all the other balls go into bin 2. So this is binomial, right? So actually this distribution is binomial. So you'll have your 5 choose 2, half squared, half power 3. Okay, I'm just writing it in a slightly laborious fashion so you can see where this is coming from. So then this is 5 choose 1, 5 choose 4 if you like, 3 here if you like, half power 4 into half, and here again you'll have just half power 5. Okay, so you can simplify this. So this is just 1 by 32, this is 5 by 32, this is 10 by 32, This is again 5 by 32. No, this is 10 by 32. This is 5 by 32. And this is again 1 by 30. Again, a good thing is to count. 1 plus 5 is 6, 16, 26, 31, 32. Okay. So that's a good thing to do. So this is the joint distribution. And interestingly, if you look at x plus y, you'll simply get 5, 5, 5, 5, 5, 5, 5. Okay. So x plus y in this case just takes one value. Okay. And if it takes one value, that should happen with probability 1. It's a constant. So x plus y is easy to write down. What about x minus y? That may not be the same. I mean, x minus y can be a bit tricky. So if you look at x minus y, you have minus 1, minus 5, minus 3, minus 1, 1, 3, 5. Okay. So in fact, x minus y is the same as x in some sense, right? So it takes 6 different values, minus 5, minus 3, minus 1, 1, 3, 5. But, they're all different. So probability that x minus y is minus 5 is simply going to be 1 by 32. Probability that x minus y is minus 3 is simply going to be 5 by 32. There is no real operation to do. I mean, two values don't occur, don't repeat. All values are distinct. So x minus y and x are more or less the same. I mean, they take the same, the probabilities with which they take values are the same, except that the values are different. So that's all. So, but if you look at min of xy, you might have a slightly more interesting situation. You have 0, 1, 2, 2, 1, 0. Okay. So min of xy has some repetition. So min of xy can take just 3 values, 0, 1, 2, and one can quickly see 0 happens at these two possibilities, so the probability is just 2 by 32. 1 happens at these two possibilities, probability is 10 by 32. And 2 happens at the middle two possibilities, probability is 20 by 32. So you can quickly do this, even though the experiment looks a little bit complicated. Any function you can easily do. This is actually quite a simple example, and x plus y became very, very simple, but the other functions are slightly more complicated, that's all. Okay, so the next example I'm going to see is it's going to be slightly different from the previous one. So I will look at 5 balls into 3 bins. Okay, so the third bin is the additional thing that happened here, but I'll let x and y be the same thing again. Okay, x is the number of balls in bin 1 and y is the number of balls in bin 2. That we won't change. Remember, there's 3 bins now. It's not just 2 bins. And then we're still throwing 5 balls. Okay, so this could go anywhere. Once you have 3 bins, things start becoming a little bit more interesting, because you can't say x and y determine each other. If I give you x, you don't know y, right? So I mean, y could be 0 or anything, right? So I mean, some things you can know, but not a whole lot. Okay, so this is a slightly more complicated situation. So if you were to start building a table, it might become a little bit more difficult than what you bargained for. So for instance, if x is 0, y can be 0. If x is 0, y can be 1. If x is 0, y can be 2, right? So all of these are possible. All the way up to here is possible. Now if x is 1, y could be 0. 1 is possible. 1, 2 is possible, 1, 3 is possible, 1, 4 is possible, 1, 5 of course is not possible. So x is 2, 0, so on. So a number of possibilities is a bit too much. You could enumerate. I'm not saying it's impossible, but it's just the number of cases just starts blowing up a little bit too much. So you'll have to use some more clever ideas. You'll see how to go about it. So supposing I say x plus y. So clearly, if you think about it, x plus y takes values 0, 1, 2, 3, 4, 5. All of the possibilities are there. Okay. Now, if you want to assign probabilities here, you can do the PMF and try looking at the cases of x and y and adding, but that will not be very efficient. Let's look at the experiment a little bit more closely. What is x plus y? What does x plus y represent? Is the number of balls in bin 1 and bin 2 together. Okay, so what you can do is you can kind of fuse these two bins together and think of it as one super bin. Okay, and probability that a ball lands here is 2 by 3, the probability that the ball lands here is 1 by 3, right? So every ball, if it lands in either bin 1 or bin 2, I have some sort of a success when I want to count x plus y, right? So I want to count x plus y. I have a contribution of 1 to x plus y every time a ball lands in either bin 1 or bin 2. And the probability of that happening is 2 by 3 in every trial. And I have five such possibilities. So one can quickly see that this x plus y is actually binomial with 5, 2 by 3. Okay. So this is a nice observation you can make based on how the problem is set up. Okay. So you can compute probabilities quite easily. So what's the probability that x plus y is 0? No ball lands in bin 1 or bin 2. So that's going to be 1 by 3 power 5. So that's the binomial calculation here. So what's the probability that x plus y is 5? All the balls land here. So that's going to be 2 by 3 power 5. Okay. So any other value you pick. So let's say x plus y is 2. Okay. So there are 5 choose 2 different ways in which this can happen. And 2 balls land in bin 1 or bin 2. And 1 ball lands in, 3 balls land in the other bin. Okay. So this is possible. One can do this. It's quite okay. But any other function is going to be a little bit more tricky. Okay. So for instance, if I do min of xy. Okay. So this is not necessarily easy. So if you do min of xy. Okay. So what is the least number of balls that fell either in bin 1 or bin 2? Okay. So so one needs to do some thinking, right? So what are the various possibilities here? X and y could be 0, 0, 0, 1, etc. So 0 is possible as a minimum value. Okay, you can see these things. 1 is also possible as a minimum value. There are several cases in which 1 will be the minimum. 2 is possible as the minimum value, right? So between just x and y. So you could have 2 here and then 3 in the next one, right? Now, once you go beyond 2, actually it's not really possible. You cannot have 3 as the minimum between x and y, right? Because if one of them had 3, the other one is going to have 2 or lesser. Okay, so then that will become the minimum. So minimum will take just 3 possibilities. So computing probabilities for even min of x, y is quite a bit complicated. It's not very easy. Supposing you want to focus on just one value, min of x, y being equal to 0, okay? So this can happen if either x should be 0 or y should be 0, and or both can be 0, right? So I have to worry about probability that x is 0, right? That you can compute. You will be able to compute that, and then I have to worry about probability that y is 0, okay? And then I have to subtract the case in which both of them were 0, so that I get the count of min of xy being 0. So this would be probability of x equals 0 plus the probability that y equals 0. Okay, so this will give you, but there's a case in which both of these could have happened, so I have to subtract the case where x is 0, y is 0. Okay, so think about why this is true. So if min of xy is 0, either x has to be 0 or y has to be 0. So if I simply add the probability, there is a case in which both x and y could be 0 together, so I have to subtract that out. So I will get all the events. Okay, so this is basically the event 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, and then 1, 0, 2, 0, 3, 0, so on. Okay, so if I just compute x equals 0, I will get one answer. Y equals 0, I'll get one answer. But this event 0, 0 would have been counted twice. Okay, so I have to subtract that. Okay, so the reason why I write like this is probability that x equal to 0 I can easily calculate. What's the probability that x is 0? No ball landed in bin 1. Okay, all the balls should land in bin 2 or bin 3. So that is just 2 by 3 power 5. Okay, and probability that y equals 0 I can also easily compute. That's again 2 by 3 power 5. What's the probability that both x and y are 0? That's 1 by 3 power 5. Okay, so this will be the answer for min of x, y equal to 0. Okay, so in various cases, I just in the last example, I just wanted to suggest that if you look at the function very carefully and understand what you need to compute, you can go about doing it. It's not really difficult, but there can be no generic method. You know, in some cases, the experiment can be really complicated, and your function can be a very, very complicated function of all the events that happen. In which case, you have to really sit down and think about what you're doing and do. Okay, thank you very much. That's the end of this lecture.